Last lesson of Unit 2, we're going to talk about combining quadrilaterals and triangle congruence proofs in one proof here. So that's our goal. We're going to prove triangles are congruent using properties of quadrilaterals. I'm going to skip ahead real quick. One thing we did in class that was super helpful, a lot of people think that the diagonals always cut the angle in half. But we see 28 plus 62, those are not the same angle. They're different, but they do add up to 90 degrees because the corner of a rectangle is always 90 degrees. So no matter where I move this, right, I can make this smaller, bigger. The angle always adds up to 90. 70 and 20 adds up to 90. 60, 30, 59, 31. Those add up to 90. The only time the angle is cut in half, when it would be exactly in half, this would be a square. All the sides are 4.8. Desmos just rounds like to the hundredths, so it's really 4.8. So the only time that angle is going to be cut in half is if the shape is a square. So rectangle, it's not cut in half. Square, now it's cut in half. So just one thing to notice. See, now it's not a square anymore, not cut in half. All right, so that's what we did in the beginning of class there. But there are two ways to prove triangles are congruent. We can use rigid motions, right? For this one, it would be a reflection to map one triangle onto the other. Or we could prove three pairs of sides or angles using the postulates. So I got two sides equal here, another pair of sides equal, and that reflexive property. So this is side, side, side. So that's the other way to explain it. So there's two ways to do it. We're going to really work on the first example using rigid motions and then using a triangle congruence proof. So for the rigid motion, to prove these two triangles are congruent, WZY, this triangle, is congruent to WXZ, this triangle, I could say reflect triangle WZY over segment WY to map onto triangle WXY, and then let's say WZ lands on WX, ZY lands on XY, showing the triangles are congruent, right? We would just flip over this line would land here, boom, perfect. This line would land here, we flip over onto XY, so we have those two triangles are congruent. If I wrote this in a proof, I'm given WZ is equal to WX, I see that with the tick marks, and ZY is equal to XY. I also know WY is equal to YW using the reflexive property, right? That side of the triangle on the left is the exact same length as this triangle because it's the exact same line. That triangle or that line is equal in both triangles. That's the reflexive property. Therefore, we know, I'm just going to copy and paste this so I don't have to type it. Copy, paste. By side, side, side. We have three pairs of sides congruent. So there are two ways to do this. We could use rigid motions. We could use a proof. So there's some partner practice where you want to use properties of parallelograms to prove the triangles are congruent. Use some rigid motions. And then that cool down is just to explain, how do you know this angle is 45 degrees based on this picture?